Problem number 1. Hydrogen fuel can be generated using a process called coal gasification. Hydrogen gas is formed by the reaction of carbon, excess oxygen, and excess water. 3 carbon from coal plus O2 plus H2O reacts to form H2 plus 3CO. If this process has an 84.22% yield, what mass of coal, 65.5% coal by mass, carbon by mass, is needed to generate 1.33 kilograms of hydrogen. So we know we have an 84.22% yield. We know that the coal is 65.5% carbon by mass, and we know that we have 1.33 kilograms of H2 at the end. So what we're looking for. For the carbon, we know that we have 65.5 grams of carbon per 100 grams of coal. So we'll use that later. So first we will start with our the stuff we know. So we'll start with 1.33 kilograms of H2 actual, and we will convert that to grams of H2, and then we will use our 100 grams theoretical H2 over our 84.22 grams of actual H2, because that is what the percent yield ratio is, but it's flipped. We know that theoretically one mole, or we know that 1 mole of H2 is 2.02 grams of H2, and we know that 3 mole of carbon equals 1 mole of H2, and then we will convert that from grams carbon to moles of carbon, and then we will use our 65.5 grams of carbon under 100 grams of coal to get our grams of coal. Problem number 2. A sample of a mixture of CaCO3 and NaHCO3 was heated, and the compounds decomposed as follows. CaCO3 reacts to form CaO plus CO2, and 2NaHCO3 reacts to form Na2CO3 plus CO2 plus H2O. The decomposition of the sample yields 5.193 grams of CO2 and 0.4826 grams of H2O. What percentage by mass of the original sample was CaCO3? First, we have to find the mole of H2O to moles to CO2, to find grams of CO2 from NaHCO3, and then we have to find the mass of CO2 from mass of CaO3 by subtraction. We have to find the mass of NaHCO3 in the mixture. We have to find the mass of CaCO3 from CO2 and in CaCO3, and then we can find the percent mass of CaCO3 in the mixture. So to start off, we need to find grams of CO2 made by NaCO3. So we start with the H2O, so we start with grams of H2O, then we convert from grams to moles of H2O, and then we know the 1-to-1 ratio of moles of H2O to moles of CO2, and then we convert from moles CO2 to grams of CO2. To find the mass of NaHCO3, we will use the grams of CO2 we just found, convert that from grams to moles, and we know there is 1 mole of CO2 for every 2 moles of NaHCO3. Then we'll convert from moles to grams, and we will get our grams of NaHCO3. To find the grams of CO2 from CaCO3, we subtract from the 5.193 grams CO2 total, we subtract 1.179 grams CO2 from NaHCO3. Using the 4.014 grams CO2 that we just found, we then convert when we know the ratio is 1 mole CO2 to 1 mole CaCO3, and then we convert from mole CaCO3 to grams CaCO3, giving us 401.8 grams of CaCO3, and then we add 4.014 0.001 grams NaCO3 to get our total mass, and then we divide the grams of CaCO3 divided by the total mass of the mixture times 100%, and then we get our final answer, which is 98.90% CaCO3. Problem number 3. A hormone released by the human body during stress was isolated. Like many biological compounds, it is composed of carbon, hydrogen, oxygen, and nitrogen. The compound had a formula C9H13NOx. Analysis shows that the compound was 58.9% C. Calculate the integer x. First, we're going to find moles of C. So we'll use our 58.9 grams of C over 100 grams of compound because that's the percent ratio. And we'll convert from moles to grams, and we will get our grams of carbon. Then we want to find the mass of H, but we're going to do it in 2 steps so we can save the moles for later. So we have our 4.9 moles of C, and we know that there are 13 moles of H for every 9 moles of C, which equals 7.08 moles of H in a 100 gram compound. And then we will go from 7.08 grams of H and convert to grams, so now we have both moles and grams of H. Then we will find the moles of N in the same way, using 4.9 moles of C, and then using the ratio of 1 mole of N per 9 moles of C. And then we will use our 0.544 moles of N, and we will convert from moles of N to grams of N to get 7.62 grams of N. Because we used the percent, we know that we have 100 grams total, so we'll subtract from that 100 grams 58.9 grams of C, 7.15 grams of H, and 7.62 grams of N, leaving us with 26.33 grams of O. Then we will use that and we will convert from grams to moles, leaving us with 1.65 moles of O. Now all we have to do is take since N has the smallest mole, as we found out before, we just have to divide the 1.65 moles of O that we got by the 0.544, and we get O3. So we know that O is 3, meaning X equals 3.